Hello everyone, myself Dipali Jain and I am working as an assistant professor in KKV College of Pharmacy, Nashik. Today I am here with the second part of extraction technique, that is liquid-liquid extraction. So let us start with the definition of extraction. So what is meant by extraction? It is the separation technique which is used to separate the active constituent from mixture. Solubilizing the active constituent and removing it with a suitable extracting solvent is the most common technique followed in the field of analysis. Okay, so this is the definition of extraction. Now let us start with the main part of our method, that is liquid-liquid extraction. Definition of liquid-liquid extraction technique. So this method is also known as solvent extraction, which involves the separation of the constituent or solutes of a liquid solution by contact with another insoluble liquid. Solutes are separated based on their different solubilities in different liquids. Separation is achieved when the substances constituting the original solution is transferred from the original solution to the other liquid solution. So this is the principle behind liquid-liquid extraction technique. Firstly, we taken two solvents. Okay, in first solvent there is solids is present. Okay, here you can see in the diagram filled solution with a heavy phase with mixture of solute, and this is the light phase or solvent. After the mixing or stirring or shaking, they both solvent phases are dispersed to each other. Okay, and it is divided into two phases. That is dispersed phase and continuous phase. So in third step, you can see here phase separation is occur. Okay, so this is the extract with solute and this is raffinate with non-extracted solute. So liquid-liquid extraction technique is divided into four steps or four compartments are required, that is solvent, solution, extract and raffinate. Here you can see when we mix the two phases and after that there is separation is occur. So it is divided into four steps. So the simplest liquid-liquid extraction involve only a ternary or three component system. The solution which is to be extracted is called the feed and the liquid with which the feed is contacted is the solvent. The feed can be considered as comprising the solute A and the carrier liquid C. Solvent S is pure liquid. During contact, mass transfer of A from the feed to the solvent S occurs with little transfers of C to S. The solvent in which solute is present is then permitted to separate from the carrier liquid. The solvent-rich product of the operation is called extract, and the residual liquid from which solutes has been removed is the raffinate. In some operation, the solute are the desired product, hence the extract stream is desirable stream. In other applications, the solutes may be contaminants that need to be removed, and in this instance, the raffinate is the desirable product stream. This technique is based on Nernst law, which states that the ratio of activity of a solute species in a pair of two immiscible liquids at an equilibrium constant. So in this liquid-liquid extraction, the separation is based on the partition coefficient ratio. Okay, so first upon we will see what is meant by distribution coefficient. Two immiscible solvents are in contact with each other and a solute or substance that is soluble in both solvents is added to it. Then the substance will distribute itself in both solvents in such a way that the ratio of concentration of two solutions is a constant. This phenomenon is referred as distribution coefficient or partition coefficient. It means the separation of the phases is depend on the distribution coefficient. So it is denoted or it is mentioned by the equation, that is K is equal to Cu by Cl, where K is distribution coefficient, Cu means concentration in upper phase and Cl means concentration of solute in a lower phase. In distribution coefficient or partition coefficient, the amount of volume of liquid phases used hold important factor. It is necessary either to use large volume of extracting solvent for single extraction or better to use small successive portions of extracting solvents to bring complete extraction. It also makes clear that larger the partition coefficient, larger will be the solute found in upper phase after equilibrium. Okay. So next definition is distribution ratio. So what is meant by distribution ratio? It is the ratio of concentration of all species of solute in each phase of solvent, and it is denoted as D or Kp. This differs from distribution coefficient, means this distribution ratio and distribution coefficient, these two phases are different. Okay, this distribution coefficient, which gives the ratio of undissociated or unionized solute in a pair of immiscible liquids. Many substances like weak acids get partially ionized in aqueous media. The pH of aqueous phase brings marked effect on the extraction of such acids. Let us consider the distribution of benzoic acid between ether and water as per distribution coefficient. So K is equal to HBZ, or this concentration of benzoic acid in ether divided by concentration of benzoic acid in water. Okay, so let this distribution coefficient be the ionization constant, then as Ka is equal to H into Bz divided by HBZ. Okay, so distribution ratio, which is denoted by D or Kd, is equal to HBZ in ether divided by HBZ in water plus benzoic acid in water. The relationship with distribution coefficient K is given by D or Kd is equal to K divided by 1 plus Ka divided by hydrogen present in water. Okay, so this is about the distribution coefficient and distribution ratio relationship. This equation predicts that when H hydrogen ion is greater than partition coefficient constant, D is nearly equal to Kd, and if Kd is large, the benzoic acid will be extracted into the ether layer. D is maximum under this condition. If on the other hand hydrogen is lower than partition coefficient ratio, then D reduces to Kd, that is H plus A divided by Ka, which will be small, and the benzoic acid will remain in the aqueous layer. Next phase or next step is separation factor. It is denoted by beta. It is the ratio of K1 divided by K2, wherein K1 refers to the distribution of solute 1 in a pair of equal volume of solvent, while K2 refers to the distribution coefficient of solid 2 in the same pair of solvent. If the ratio turns into unity, then the two substances cannot be separated out. Greater the deviation of beta from unity, greater is the ease of separation. Now let us see the types of liquid lipid extraction method. It is divided into two steps or two types. First one is single extraction. It is also known as batch type, and second one is continuous extraction. So let us start with the first extraction method, that is batch extraction. This is most simple and widely used method. This method is applicable for a solute having large distribution ratio. In this method, solute is extracted from one layer of liquid by distributing it with a second immiscible liquid using separating funnel. For more effective and complete separation, many times extracting solvent is divided into portions and multiple extraction are carried out. So this is about the principle behind batch extraction. So here separating funnel is used for this method. Okay, so here in the diagram you can see analyte with solvent firstly placed into the separating funnel, then add immiscible solvent. Okay, then shake the two layers. After that, separation is occur in the separating funnel. This is the blue line. Blue color is considered as a lower density liquid and yellow considered higher density liquid. Okay, and in that solute is present. So this is the funnel cap. After the losing this cap, you can see here higher density liquid is removed, okay, into the beaker. So this here we use solvent system. solvent if this is the less dense liquid and this is the more dense liquid. Okay, so here oil is used as a solvent and solute is non-polar. Okay, and if we use solvent as a water, then we use solute ionic or polar. If more dense solvent is water, then we use solute ionic or polar. And here you can see yellow part means if the solvent is chloroform, then we use solute as a non-polar. Okay, so here more organic solvents use in which compounds are soluble, and if uh, we use water, then water soluble compounds are separate out. Okay, so two immiscible liquids, that is ether and water, are used. Okay, so if there is organic solvent, uh, they are used to separate out the organic compounds, and water is used to separate out the water soluble compounds. Second type is continuous extraction. This method of extraction is carried out when the distribution ratio is low. The method makes use of continuous flow of immiscible solvent through the solution to be extracted. Although distribution equilibrium is never reached during the time of contact, solid gets removed continuously by the passing or flowing solvent. For this method, special type of continuous liquid-liquid extraction apparatus is used. Continuous extraction apparatus are of two types: extracting solvent lighter than sample solution and extracting solvent heavier than sample solution. So here you can see two types of apparatus are used for this continuous extraction method. Okay, so first one is heavier than water and second one is lighter than water. Okay, so let us see the principle behind this continuous extraction method. So first type, extraction of lighter type. It consists of a flask A, main body of the thimble B, and condenser C. The size and dimension of the apparatus vary depending upon the quantity to be used. A suitable extracting solvent that is lighter than sample solution or ether is placed in flask A. It is connected to the body B, which holds sample solution up to its half capacity. In this is place a glass tube having funnel shape opening at one end and a glass bulb with holes at another end. This body is then connected to the condenser. Okay, so here you can see this is the instrument or apparatus which is used for the extraction when solvent is lighter than the sample solution. The solvent in flask is heated. Vapor of solvent pass through the condenser and fall as a droplet into the funnel type glass tube. The droplet escapes through the bulb and being lighter passes through the sample solution. In the process, it extracts solute and gets accumulated on the top of the sample solution. When sufficient quantity gets collected, it overflows back to the flask. This process is continued till complete extraction is effected. As we know, this apparatus is divided into A, B, C, three parts. Okay, so this is about the extraction procedure in which solvent is used which is lighter than the sample solution. Okay, now second subtype is extraction of heavier type. This apparatus is used which is similar as a first type. Okay, so this apparatus is similar to the former type but differ in design. In this diagram you can see there is a difference in between two instruments. Okay, the extracting solvent heavier than aqueous solution is placed in flask A and heated. The vapors pass from side tube of the body of apparatus B to the condenser. On a cooling, the droplet of solvent pass through sample solution and gets accumulated at the bottom of the body of the apparatus, from where it overflows into the flask. Okay, so this is about the extraction of heavier type than the sample solution. This achieve complete extraction. Okay, so this is apparatus which is used for the heavier type of extraction. Okay, so here two types of apparatus are used for lighter type and heavier type. Same apparatus system but minute changes occur. Okay, so here you can see a tube is present. This diagram show the separation method. Okay, So in first step, here you can see two immiscible liquids are mixed together and they go for separation. Okay, so extract 1 is obtained and remaining portion, which is known as raffinate, is further mixed with the fresh solvent. Okay, then again it is undergo for the separation and extract 2 is obtained and remaining portion, that is raffinate 2, is further mixed with the fresh solvent. Okay, so this procedure is go on. So that's why it is known as multiple contact system with fresh solvent. Okay. Now it is also divided into third type, that is counter current distribution. So liquid-liquid extraction method is commonly used to separate constituents by employing separating funnels. If a mixture contains two or more substances having similar distribution coefficients, then more extractions using large number of separating funnels will be required. This process is very inconvenient and modifications are needed for effective separation. One of such modified method is a counter current distribution, which is denoted by CCD. It is a refinement of basic liquid-liquid extraction which permits separation of substances with very similar distribution behavior effectively. The term counter current means that two phases move in opposite direction, that is in counter current fashion. So for this purpose, or now in order to achieve multiple extractions simultaneously, a special apparatus is used which is known as Craig apparatus. So this is the Craig apparatus. Okay. The apparatus consists of series of special type of separatory tube connected such that the outlet of one tube flows into the inlet of the next tube. Here you can see in the diagram, outlet and inlet of tubes are connected with each other. Okay, so this is the upper tube B and this is the lower tube, which is denoted by A. The size and shape of the tubes vary depending upon the volume of liquid phases to be handled. The tube known as upper and lower are identical in such and are connected such that they can hold liquid phases and allow transfer of lighter or upper phase liquid to flow into the other tube. Okay, so this is the working principle of counter current distribution method. Okay, so this Craig apparatus is used for this method. Sample is introduced in lower tube number 1 is fixed volume of lower phase liquid. Similarly, other lower tube are charged with fixed same volume of lower phase liquid. Now, upper tubes are also filled with equal volume of upper phase, that is extracting liquid. The upper tubes are connected with next number of lower tubes and the assembly is rocked back and forth through an angle of 45 degree around P or P. Okay. After equilibration has been achieved, the assembly is rotated 90 degree and upper phase solvent is passed into next tubes holding lower phase liquid. Such shaking and equilibration is carried out many times. All separation is affected. Hundred of such assemblies are mounted side by side and all rocked and rotated simultaneously by a motor timed to operate as directed. Now let us see some factors which affect this technique, that is liquid-liquid extraction method. Okay, so number of factors affect the distribution coefficient of a solute. This can be utilized for affecting separation quantitatively and satisfactorily. So such factors are: first one is choice of solvent, second one is pH effect, third one is salting effect, fourth one is control of hydrophobicity. Now let us start with the one by one. So first one is choice of solvent. The extracting solvent should have following characteristics. First one is high distribution ratio for the solute. It should have low viscosity and sufficient density difference. It should have a low toxicity and inflammability. It should be cheap, easily available and should have easy recovery. Now second factor is pH effect. So pH plays an important role in extraction process. Many compounds encountered by pharmaceutical analysts are weak acids or bases. Solubility of these substances depend upon their ionic form. Generally, ionized species are soluble in polar solvents and non-ionized in non-polar solvents. These forms can be interconverted by adjusting pH of medium. Hence, pH control is most powerful means for influencing the value of partition coefficient. Now, next factor is salting effect. In the extraction procedure, this phenomenon is widely adopted. If the salt concentration of aqueous phase is raised very high, then the solubility of non-electrolyte in aqueous phase will be reduced. This helps in having more effective extraction by the organic solvent. The reduction of solubility by increasing the ionic strength is known as salting out effect. Okay. For example, in extraction of ephedrine from its salt, the solution is made alkaline and then large quantity of sodium chloride is added to the aqueous phase. Okay. The ephedrine base is then extracted out using solvent ether. Next factor is control of hydrophobicity. The partition coefficient of an ion can be altered by making the ion more hydrophobic. In two-phase system, that is aqueous and organic phase, ions are normally expected to partition almost completely to the aqueous phase. If hydrophobic counter ions are added, so ion pair may be hydrophobic enough to partition into organic phase. Another way is use of microcyclic sequestering agent such as chrome ether. So let us see the applications of extraction method in drug analysis. So this method is applicable for the separation of elements, then for concentrating impurities. It is also used for clearing of the basic components from impurity in the process of synthesis of substances of drugs. It is also applicable for identification of basic components from impurities in the process of synthesis of the drugs. For the identification and quantitative analysis of chemical substances in the process of analysis of photogenesis drugs. It is also used to increase the selectivity and sensitivity of the reactions. It is used to study the formation constant of complexes. It is used to study the condition of substance in a solution, that is polymerization degree or a charge of the substance. It is also useful in the treatment of extract, tinctures, antibiotic preparations from different biological products. Okay, so these are the application of extraction method. Now let us see the question bank related to the extraction method. So there is some MCQ type. First one is solvent extraction is more effective when the extraction is repeated with options are extra solvent, B large solvent, C small solvent or D no solvent. So answer is C. Here explanation is also given. Why C? Because solvent extraction is more effective when the extraction is repeated with a small amount. Okay. Next question is when the component has a small value of K, it is supposed to have an affinity for options are mobile phase, no phase, stationary phase or whole solution. And answer is option C, that is stationary phase. The component has a small value of K, it is supposed to have an affinity for stationary phase. Next question is what is the use of ether layer? Options are to separate the organic impurities, to separate the inorganic impurities, to separate the fibers or to separate the solvent. And right answer is option A. Since ether is a non-polar compound, so its layer is used to separate the organic impurity. Next question is a mobile phase cannot be options are gas, solid, liquid or solid or gas. So right answer is option B, that is solid. A mobile phase has to flow and hence it should not be a solid. Okay. Next question is what is the representation of distribution coefficients? Options are S, H, G or K, and right answer is option D, that is K. Next question is the dispersed phase is also known as options are non-continuous phase, continuous phase, discontinuous phase or gas phase, and right answer is option C, that is discontinuous phase. Next question is the dispersed phase is options are continuous, heavier, lighter or maybe heavier or lighter, and right answer is option D, that is maybe heavier or lighter. Next question is one of the following is observed in extraction. Options are heat transfer, fluid transfer, energy transfer or mass transfer, and right answer is option D, that is mass transfer. Next question is, extraction does not involve one of the following component. Options are active constituent, vapor, solvent or crude solids. And correct answer is option B, that is vapor. Next question, extraction is different from expression in one of the following. Options are active constituent, solvent, size reduction or crude solids. And correct answer is option B, that is solvent. The next question is, extraction of drug involve CO2 belongs to following type. Options are expression, liquid-liquid extraction, leaching process or solid-liquid extraction. And correct answer is option B, that is liquid-liquid extraction. Next question is, solvent extraction is a analytical technique. Options are separating, quantitative, qualitative or identification test. Okay. So correct answer is option A, that is solvent extraction is a separating analytical technique. Next question, the other name of solvent extraction is, and options are solid liquid extraction, liquid liquid extraction, solid solid extraction or liquid gas extraction. Correct answer is option B, that is liquid liquid extraction. Next, solvent extraction is governed by which law? Options are Oswald equation, Nernst distribution law, Boyle's law or Beard's law. And correct answer is option B, that is Nernst distribution law. So these next are the long question answer type questions. So here questions are, define extraction method, give its principle or give the principle of solid phase extraction. Then describe instrumentation and application of SPE. What is meant by solvent extraction? Explain principle involving liquid-liquid extraction technique. Define distribution coefficient and distribution ratio. Discuss factors affecting liquid-liquid extraction technique. Write the applications of liquid-liquid extraction. So these are the questions which is useful for your study. Thank you.